Hello dear students, fine. Today we are going to discuss about the system of particles and rotational motion. In that first what we are going to discuss means we are going to discuss about the center of mass. So what is meant by center of mass means first. So center of mass means it is a location where mass of particle or system of particles is assumed to be concentrated. Is called what here? Center of mass, which we can tell here. So for example, if we take any reference here, we are taking one reference. This is x-axis, this is y-axis. So let us assume one mass particle is there at this point, which is having mass m1. From here, distance is what you are choosing means with coordinates vector I am choosing r1. Let us assume another mass m2 is there here. So from a coordinate, how much will get it? r2. Here mass m3 is there, coordinates how much is there? m3, r3. Here mass m4 is there. From origin, distance is r4. Now what we are choosing means we are assuming somewhere here total mass of the these all particles is assumed to be concentrated. This is called center of mass. Simply we can write COM here. So from here to here, distance what we can write it means we can write like this, RCOM. This is called center of mass. So to equation what we need to calculate this means we know that RCOM equal to M1R1 plus M2R2 plus M3R3 and so on divided by M1 plus M2 plus M3 we can write it. For example, if you want to write for about x-axis, XCOM can be written as, in the place of R1 what we need to write? X1 coordinates we need to write M1 x1 plus M2 x2 plus M3 x3 divided by M1 plus M2 plus M3. So simply this can be written as XCOM can be written as what we can write? Sigma mx divided by sigma m we can write it. Mx means m1 x1 plus m2 x2 plus m3 x3 and so on we can write it like that. So next what we are going to do here is YCOM. YCOM if you want to do YCOM equal to what we can write it? Sigma my by sigma m we can write it. ZCOM if you want to write it means what we can write it? ZCOM equal to sigma mz by sigma m. For example, for Z if you want to write it, expand that formula. ZCOM can be written as what we can write it here? M1 Z1 plus M2 Z2 plus M3 Z3 up to here Mn Zn we can write it. Divided by M1 plus M2 plus M3 we can write it here. So here this is the main formula which we have to remember. So remaining all we can come from this formula only, and this we can mention this formula in terms of vector form also we can mention here. We discuss about two particle system. 2-point mass I am going to discuss. 2-point masses. So let us take 2-point masses we are having. This is mass m1, this is mass m2. The distance between these two they given like r. So where does center of mass will come? Somewhere here center of mass will come. Let us assume here this is center of mass point. We need to find center of mass coordinates. So for example, if you assume here about m1 I want to calculate center of mass, I have to choose this is my coordinate axis. So on this axis, y axis so much 0, x axis also much it's starting from origin 0 we can choose here. So now to where we need to calculate where the center of mass is locating, we need to check. What is the formula we are having? We are having formula here. About x-axis we are discussing. These coordinates will become how much? R, 0. Therefore, XCOM can be written as what we get it? M1 x1, M1 r1 plus M2 r2 divided by M1 plus M2. We can write x1 also. Therefore, XCOM can be written as M1 x1 value is how much? 0 This point will become 0. 0 plus M2 in the place of R2 what we are having? R we are having. R divided by m1 plus m2. Therefore XCOM equal to what will get it means m2r divided by m1 plus m2. Means from x-axis to center of from mass 1 to center of mass, what will get it here? Distance m2r divided by m1 plus m2. Similarly, if we consider this is your coordinate axis, what will get it here? Distance means here will get like m1r divided by m1 plus m2 will get your distance here. Okay, so that's what we'll get here. Now let me check a numerical here. For example, they given like this. Example question. They given this is like m, this is like 2m, and this is the line joining them. This distance is how much means r they given here. Now this is the center of mass we are assuming here. So center of mass we are assuming means from here to x-axis to that fellow how much, from y-axis x-axis to other mass to there how much distance we need to calculate. So what we got it here, XCM equals to this distance, how much we got it, m1r divided by m1 plus m2. m1 is how much, m2 is how much, 2m. So mr divided by m2r, right, m2r. So 2mr divided by m1 plus m2. m1 plus m2 is nothing but 3m, right, 3m. This distance if you want to calculate, m1r divided by m1 plus m2 na. So m1 value is how much, mr divided by m plus 2m, m plus 2m, that equal to mr divided by 3m. So what will get it here, this distance is mr divided by 3m will get it. This distance is nothing but 2mr divided by 3m will get it. Fine, let me change the slide. Let me discuss one JEE 2020 question here. JEE, what is the question? JEE 2020 question. In that question, what they're asking means here, they given one right angle triangle like this. This right angle triangle, at this point they placed 1 kg mass, at this point they placed 1.5 kg mass, at this point they placed 2.5 kg mass, and this side is 4 centimeters they given, this side is 3 centimeters they given. Now we need to calculate center of mass about this point. I am choosing this is my axis. Means if you want to write coordinates for this, no, 0, 0 I can write it. For this fellow, if you want to write about x-axis 3 cm, y-axis 0, 3, 0. About this, if you want to write coordinates, no, 0, 4, which we can write it here. Now, first we need to calculate XCOM. XCOM, let us assume somewhere here center of mass will come, assume. XCOM can be written as what here? m1x1 plus m2x2 plus m3x3 divided by m1 plus m2 plus m3 will get it. Therefore, XCOM equal to m1 is how much? 1, x1 is how much? 0. 1 into 0 plus m2 is how much? 1.5 into 3. 1.5 into 3 plus m3 is how much? 2.5. 2.5 into 0 x3 divided by m1 plus m2 plus m3. 1 plus 1.5 plus 2.5. 1 plus 1.5 plus 2.5. This tends to 0 because 1 into 0 0. 2.5 into 0 will be 0. This tends to 0. 1.5 into 3 nothing but 4.5 nana. Therefore XCOM equal to what will get it here? 4.5 divided by 5 will get it here. So 5 5 is a 40, 5 9 is a 45, right? So it will goes around 0.9 times will get it. 0.9 centimeters will get it here. Now if we solve about this fellow, YCOM what we can get it? m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3 we can write it here. Therefore YCOM can be written as what? m1 is how much? 1, y1 is how much here? 0 plus m2 is how much? 1.5, y2 is how much? 0 plus m3 is how much? 2.5 into coordinate is how much? 4 we are having here. So 4. Therefore divided by m1 plus m2 plus m3 value is how much? 5 we are having. Therefore 2.5 into 4 will be how much will get it? 10. 10 10 by 5 will be 2, you will get it. Therefore 2 centimeters you will get it. Therefore center of mass coordinates, if you want to write it now, about x-axis how much we got it? 0 0.9, 0 0.9 comma y-axis we got like 2, no? 2, we can write it. This is how we can indicate the center of mass. This is JEE 2020 question. So you just have to know basic concept, then we can solve this question easily. Let me discuss about next question. This is one standard question in every textbook which we can see here. So let me take, this is our x-axis or y-axis. Y-axis let me take generally. This is we are choosing like our x-axis. So we are having one body like this. Here one mass is there. About this point another mass is there. Here one mass is there. About this point another mass is there. It's framing one system like this. And this axis making an angle of 60 degrees here, and this axis also making an angle of 60 degrees. So this side length they given like L. So if you want to write first, we have to choose coordinates. For every mass value how much they given? M only they given. Now we need to choose the coordinates first. How to choose the coordinates? You should know how to break the vectors. Fine. First, if you want to write, no, this is origin, no. For this mass 0, 0 I can write it. This side length L they given, no. For this fellow how much we can write it here? X-axis L, 0 we can write it here, coordinates. Now about this mass we want to write coordinates. If you want to write coordinates, no, we can break into vectors. This side what will get it here? L, if you break into, no, L cos theta. This can be written as what here? L sin theta. L sin 60. L sin 60 is how much? Root 3 L by 2. L cos 60 is nothing but L by 2. Means this coordinates can be written as what? X-axis L by 2. Y-axis is nothing but root 3 L by 2. We can write it. Similarly, if you want to write for this fellow, no, this side will get it how much here? Root 3 L by 2. From here, how much will get it? L by 2, you got it. But if you observe, no, for this x-axis you want to write now, we should write from here, about this point. From here to here, how much distance it's traveling? Total, from here to here, it is L, up to here. This is nothing but L by 2. So, total is nothing but 3L by 2, na? This coordinate can be written as 3L by 2, about y-axis, how much it's traveling? Root 3L by 2. This is the coordinates which you have to choose here. If you choose coordinates, then remaining will be easy. So XCM we need to check. XCM how to check? XCOM can be written as M1x1 plus M2x2 plus M3x3 plus M4x4. 4 particles are there. Divided by M1 plus M2 plus M3 plus M4, which we can mention here. So now if you want to write XCOM, no, M1 value is how much? M. X1 value is how much? 0. M2 value is how much? M. X2 value how much? 0. 0. L. M. L. Plus M3 value how much we are having? Let me choose this fellow. M. And L. X3 value? L by 2. Plus M4 value? M. 3L by 2. Divided by M plus M plus M plus M, that's nothing but 4M, which will get it here. So and this tends to what? 0 here. So ML, so XCOM can be written as what here means? 3ml by 2 plus ml by 2, that's nothing but 4ml by 2. 4ml by 2 divided by 4m. These 2 1 ja, 2 2 ja. So this m also will get cancelled. 2 1 ja, 2 2 ja. Therefore XCOM can be written as what here? L by 2 will get it here. Let me check once again. ml plus 3ml ml by 2 plus 3ml by 2. 3ml by 2 plus ml by 2 is nothing but 4ml by 2. 2 1 ja, 2 2 ja. So 2ml. 2ml divided by 4m. 1m will get cancelled. 2m we got it. L by 2. Yes, if you observe here, no, just this ml we skipped here. Okay. So what we got it here? 2ml is it? 2ml plus ml is nothing but 3ml. Let me write that thing down. XCOM equal to 2ml plus ml is nothing but 3ml. 3ml divided by 4m. That's nothing but mm will get cancelled. 3l by 4 will get it. This is a coordinates and this is small correction is it? Just correct this. And we need to calculate similar way YCOM. So I am giving you people to calculate YCOM and calculate. So similar way, what is the formula? M1 y1 plus M2 y2 plus M3 y3 divided by M1 plus M2 plus M3. Similarly, we can calculate. Now, let me go to another question here. This is one of the most important standard model for every competitive exam as well as CBSE exams here. So let me check that question what they given here means. They are giving question like this. 1 kg and 2 kg particles are kept at origin. Okay. 1 kg and 2 kg particles are kept at origin. 3 kg and 4 kg particles are kept at 1 comma minus 1 comma 1. Find location of 5 kg particle such that center of mass lies at 2 comma 1 comma 2. The given center of mass coordinates, we need to calculate 5 kg particle location, we need to calculate. See, fine, this thing you need to go with vector notations. If you go with vector notation, vector solving, this question will become very easy. First question what they given, let us assume, understand first. 1 kg and 2 kg particles kept at origin. 1 kg plus 2 kg is nothing but 3 kg. So 3 kg they placed at origin means coordinates I am choosing 0 comma 0 comma 0. And next what they are telling in the question, 3 kg and 4 kg placed at 1 comma minus 1 comma 1. 3 kg 4 kg means what will happen? 3 plus 4 is nothing but 7 kg. 7 kg placed at 1 comma minus 1 comma 1. Next 5 kg particle where it is means we don't know. We need to calculate for that 5 kg particle. 5 kg particle, let me choose like x comma y comma z, that coordinates. We need to calculate x, y, z values. Now if you observe here, no, center of mass coordinates is given. Where the center of mass coordinates is given? COM coordinates is given like 2 comma 1 comma 2 we are having. So what is the formula of RCOM? RCOM is nothing but M1 R1 plus M2 R2 plus M3 R3 divided by what we are having? M1 plus M2 plus M3. Now everything I am going to keep in vector coordinates. So this can be written as what? About x-axis 2i cap, 1j cap, 2k cap. So that's the RCOM. No? Let me write that. Understand properly. 2i cap, j cap plus 2k cap is equal to M1 value 3. So this is nothing but 0 I cap, 0 j cap, 0 k cap. Still again it will comes like 0. Next 7 I cap minus j cap plus k cap. I cap minus j cap plus k cap plus 5 into these things. Just take like r vector, we can solve. We need to calculate that r vector divided by m1 plus m2 plus m3. 3 plus 7, 3 plus 7, 10, 10 plus 5 is 15. I am writing here directly 15. Now switch this 15 to LHS side here. So if we switch here, no, 15 to 30. 30 I cap plus 15 j cap plus 30 k cap. This will become 0 and open bracket here. So if you open bracket, no, 7 I cap minus 7 j cap plus 7 k cap plus what will get it here? 5 r cap, which we are having here. Now shift this I cap, j cap, k cap to LHS side here. If you shift, now what will get it? 30 minus 7 is how much will get it? 23 I cap. 15j, if minus comes here, it will become plus again. So 15 plus 27 is nothing but 22. 22 j cap plus 30 minus 7 is how much? 23 k cap is equal to 5 r vector. Therefore r vector can be written as what? 5 send this side. You'll get like 23 I cap plus 22 j cap plus 23 k cap divided by 5 divided by 5 divided by 5. Therefore we got these coordinates. X coordinates 23 by 5, y coordinates 22 by 5, z coordinate 23 by 5. You can mention that coordinates. 23 by 5 we got it, 22 by 5 we got it, 23 by 5. These are the coordinates which we need to calculate here. This is very standard question, we have to understand very well. Mass systems we have done. Let me discuss about the non-point mass. Okay. Non-point mass system. We are going to discuss about non-point mass system. So let me consider one system like this. We are having any body here like this. Let me choose. Now earlier what we are having, for all particles we had RCM. Simply RCOM can be written as sigma RM divided by sigma M we used to write. But this is non-point mass. You have to take one small part, one strip you have to take. So from there to origin, what is the distance you need to calculate? So the small strip mass is how much we are using? dm. Then we have to calculate RCM by integrating. RCM can be written as, in the place of summation we will get integration. Integral R. In the place of total mass what we are having, small portion we took here, dm, divided by what we can get here, integral dm. This is the main standard formula which you have to remember. And mass densities we have to discuss here. dm value for linear means what we get it, lambda into dx here. Lambda is nothing but linear mass density. Next, dm equal to, for area is nothing but sigma dA. Sigma is nothing but surface mass density. dm equal to rho dV, where rho is nothing but volume mass density, which we can discuss here. So let me have one question here, we can understand better. So let me choose question. A rod of length L having linear mass density lambda equal to lambda naught by L times the x. Find center of mass for the system. So what they given here? They given one rod here. So let us assume one rod they given which is having length L. So first what you have to do, up to x तक जाके dx strip लेना चाहिए. So up to x, so you have to go up to x. You have to choose one small strip here, that is dx. So for that small value mass, how can you write it? Means dm can be written as what means lambda into dx. But in the question lambda value they given like lambda naught by L into x. Therefore dm value will get like lambda naught by L into x dx. will get it here. So how to get xcom value? Xcom equal to, you know that, integral x dm divided by integral dm. Therefore if you observe here, no, integral x dm value how much we are having, this much, na, lambda naught by L into x dx divided by integral dm value lambda naught by L into x dx. So lambda naught by L will get cancelled. Integral x dx we are having here, and let me write this formula here. Integral x into x will be x square dx. X square dx is here divided by integral x dx. So what will get it here? X square by 2 you will get it here. X square by 2 divided by x cube, na, sorry, x power n plus 1 by n plus 1. X power n plus 1 by n plus 1. That's nothing but x cube by 3 will get it for numerator. X cube by 3 for denominator, x square by 2 after integration. Fine, we are going to substitute the limits here. From where to where? 0 to L they are telling, no? So let me write that. So numerator what we are having? X cube by 3, right? X cube by 3 into, I am writing 2 by x square, I am writing. Limits from where to where? 0 to L. 0 to L. 0 to L. So what will it means of substituting L cube by 3 into 2 by L square will get it. So L square 1L will get cancelled. Here what will get it? 2L by 3. This is the value of center of mass which we got it for that uniform mass system, non-uniform mass system. Discuss one more HCV question. So what the question is says means, they given one rod here and lambda equal to how much they given means A plus Bx which they given here. So what you have to do, up to x jacket dx strip ले लो. So for the dx strip, mass is how much means dm equal to lambda dx, we know, linear mass density. So if you want to substitute that value, no, lambda value you know already. Lambda value is how much? Dm equal to lambda dx, na, a plus bx into dx which we are having here. So observe carefully, xcom can be written as what here? Integral x lambda dx divided by what will get it here? Integral lambda dx. Substitute that value, dm value here, lambda dx value we get it now here, just substitute that. Integral x into a plus bx into dx divided by integral a plus bx into dx. So this can be written as what? We can open the bracket. Integral ax dx plus integral bx square dx. Because x into x will be x square, nana. Bx square dx divided by integral a dx plus integral bx dx. Here we are going to use again only one formula here, that is nothing but integral x power n dx. Integral x power n dx is nothing but what? X power n plus 1 by n plus 1. So this is a basic integration formula which we are going to use here also. What is that they given here means integral x dx by x, this level get it, no? That equal to what we can write it here. Integral ax dx, a we can take outside, integral x power n dx nothing but x square by 2, na? So ax square by 2 plus x square is there here, what will get it here? 2 plus 1 by 2 plus 1, x cube by 3, bx cube by 3 divided by, here nothing is there means what we can integral a dx nothing but a if you take outside, no, integral ax plus bx square by 2 will get it. But everywhere what is there means limits we need to apply from where to where? 0 to L, from where to where? 0 to L, from where to where? 0 to L we need to apply limits, 0 to L, 0 to L. After applying that limits, what will get it means this comes around to be AL square by 2 plus BL cube by 3 divided by AL plus BL square by 2, you can get it here. So we can take some common also, some things common. Let me check that. In previous slide equation we got like AL square by 2 plus BL cube by 3 divided by AL plus BL square by 2 which we got it. So if we take LCM, no, this can be written like this. So we have to take 3 here, we have to take 2 here, no. So 3AL square plus 2BL cube divided by, so what we can write it here? 2AL plus BL square by 2 we can write it here. Here what is there? LCM 6 is there here. So what we can get cancelled, this 6 and 3 will get cancelled, no? 2 1 ja, 2 3 ja. And from here everywhere you can take common L also here. So what we can take, check here. So here L you can take, here 1 L you can take, here 1 L you can take, for here 1 L you can take, you can cancel that if you take L and L common, no? So what we get it means here 3AL plus 2BL square divided by, here what we get it here 2A plus BL. Okay, here what is there here? L by L I took outside. This L will get cancelled. Here 3 remains, na, here. That 3 I am writing here. This is the answer for this question. This is how you have to do. 3AL plus 2BL square divided by 3 into 2A plus BL which we got it here. Center of mass for some common systems we are going to discuss here. In this what we are going to discuss means, so I am going to give one short trick to remember these all things. So what I am going to give means cinema time, Hrithik Roshan, Sridevi. Cinema time, Hrithik Roshan, Sridevi I am going to give you. So you just take C outside here, here T outside, here H outside, here R outside, S, D. for these all things we are going to give what values. So you just start from where? You just start from here. So what it means, so let me write here only dashes, that would be better. Let me start from ring here. So for ring 2 3 4 you write like this. Again from denominator you write it 2 3 4 you write it here. Short trick I'm going to give here. Next this thing you just remember like 3 8 3 pi. 3 8 3 pi. So what will get it for ring? What will get means radius will be having. So solid sphere radius, for disc radius, for hollow sphere radius, for triangular lamina what will be having means will be having like height, and for cone what will be having means height. So means what is this means cone we are having here. This is nothing but triangular lamina. This H stands for hollow sphere. Hollow sphere. R stands for ring. S stands for solid sphere. Solid sphere. And D stands for disc. These all things not complete bodies. You have to keep in mind that thing. These all bodies only half of the bodies. Cone, triangular lamina complete bodies here. And for disc, for solid sphere, for ring, hollow spheres I am given. No? So for half of the body, for example, if they given disc like this, where is center of mass locating means from this point at a 4r/3 distance, center of mass is locating 4r/3 pi. For example, they given one ring here, semicircular ring like this. For this fellow, calculate center of mass means exactly at 2r/3. What will get it? You'll get your center of mass. That is the concept which you have to understand. Let me see based on this how they can ask you numericals here. Let me change the slide here. Asking like this. Find location of point from Q where force must be applied to produce only translation motion. Only translation motion they are asking here. So this is the diagram which they gave us here. As a part of the question they given one diagram. Like this they given. They mentioned that this length is nothing but mass 2m, length is nothing but 2l, and this mass is how much m, length is l, and this end is p, this end is q, this is q, this is r they given, this is s they given. Okay. From point Q where we need to apply force to produce only translational. So if you apply force and center of mass, no, you'll get translation motion generally. Means you need to calculate where location of center of mass. So for this fellow, for this rod, uniform mass rod, no, exactly at the center total mass is assumed to be concentrated. This total mass is how much? Center of mass is nothing but center of mass for this fellow exactly at this fellow lies here. So from this total length is how much they given? Here we need to apply that force to produce what? Translation motion. Now you need to know about that point. What is the coordinates we need to know? So this is nothing but what I can tell COM point. Okay. So the total length is L they given here. So this is nothing but what we can write it here. L/2 we can write it here. So let me take this like outside. It will become like 2-point system. At Q total mass is how much is assumed? M1 I am choosing. That's nothing but 2m. At COM this point how much mass is assumed? M2 I am choosing like m. So this distance is how much is there here? L/2 is there. So if you want to know that now, so how can you apply here? You can apply from anywhere we can write it here. From about this point you can write it here. About this point if you write here now. From Q they are asking now. This is Q. This is S. Not S. PQRS T let me take. T. From Q want to take means about this point we want to choose coordinates here. So what we can write it here? Just now written formula derived at the starting of this chapter. m2r divided by m1 plus m2 we return. So the same formula I'm going to use. See here, m2 is how much? M into r value is how much? L by 2 divided by m1 plus m2. M plus 2m is nothing but 3m. 1m 1m will get cancelled. Therefore answer we got like L by 6 we are getting here. So L by, at a distance of L by 6, if you apply force here, no, so from here to here, if you apply force here, no, it will produce only translation motion. In the question nothing but we are going to find the what? Center of mass only we are going to find here. And we take one more question here. In this question what we are going to discuss means, they given two masses like this. One disc they given like this, and beside that one sheet they placed like this. Square sheet. The square sheet dimensions they given like 2r side length, and for this fellow radius how much they given means r they given. So now they didn't given masses here, we need to check mass here. How to get means, you know that for surface area we got like mass value like sigma a. So m1 can be written as what means sigma a1, we can write it here. Sigma a1 means sigma into pi r square. M1 for this fellow I am choosing. So M2 if you want to choose, no, this fellow you want to choose M2. M2 equal to what will get here? Sigma A2. Sigma A2 is nothing but 4 into sigma into 4 into A square, na, 4R square. 2R into 2R will be 4R square, will get it here. So if you observe these both now here, so M1 M2 value we need to write here. M1 M2 value how to choose? Let me choose like, this is like M1, this is like M2 somewhere. This is M1, this is M2. Let us assume somewhere center of mass is there here. So from here to here the distance is how much? Na, 0 now. Minus r comma 0 I am choosing. Minus r comma 0. From this point to this point, negative axis. Na. From this point to this point what we can choose? Positive axis. Na. R comma 0. But if you observe here now, in this what all the things common is there, I am going to remove that. So if you remove also you will get the same answer here actually. So mass M1 is directly proportional to what you write it here. M1 is directly proportional to what? Na? Sigma is common is there, r square also common is there. M1 is directly proportional to pi I am writing. M2 is directly proportional to what I can write it here. Sigma common, r square common means what I can write it? 4. Now these things we are taking and we are going to substitute in the formula. Let me take that point mass once again. This fellow. M1 value is how much we got it? Pi. M2 value how much we got it? 4 we got it. Center of mass somewhere here located. And these coordinates we got like minus r comma 0. These coordinates we got like r comma 0. So if you want to calculate XCOM, now what is XCOM formula? M1 x1 plus M2 x2 divided by M1 plus M2 which we are having here. Therefore XCOM equal to what we can write it? M1 is pi, x1 is nothing but minus r divided by plus 4 into r divided by M1 plus M2, pi plus 4. So if you take r common here, what will happen here? Therefore XCOM can be written as what here? 4 minus r divided by 4 plus 4 minus pi, we are taking r common, no? 4 minus pi divided by 4 plus pi into r we can write it. This is the answer for the question. And if you observe here sheet now, in this slide here if you observe now here, so where does center of mass locates means, so who is having more mass on that side? So this is we consider like pi here, and this is nothing but 3 pi, no? So where does locates means about this, in this sheet only we are going to present. Means they given like this. This is also one standard question. They given one semicircular bowl here and they placed one cone here like this. They're telling both are solid only. Both are solid, and this radius is how much means r is there. Okay, and question says that this fellow radius height is how much means h equal to 4r they given. H equal to 4r that given clue. Now where that center of mass locates, so we need to calculate here. See, to calculate that first we need to calculate mass 1 and mass 2. So m1 equal to what we can write it here? M1 equal to rho v1. M2 equal to what we can write it? Rho v2. M1 equal to rho v1. So what is the cone volume is, if you want to write means rho into 1 by 3 pi r square h, we know that. Pi r square h. So m2 can be written as what here? m2 equal to rho into half of the sphere volume. So 4 by 3 total, half of that means 2 by 3 pi r cube, we know that. Therefore m1 equal to rho into 1 by 3 into pi r square into, in the question the given height is nothing but 4r they given. We are going to substitute that. R square into 4r. m2 equal to what we will get it here? Rho into 2 by 3 pi r cube, which we are having here. Now r square into r will be r cube, na? Therefore m1 can be written as rho into 4 by 3 pi r cube we are having. m2 equal to rho into 2 by 3 pi r cube we are having here. So if I assume m1 like here 1, 2 by 3, this is nothing but 2 to the 4, na? This will get like m2 equal to 2 will get it. This is what we are going to assume. And for this fellow, where does center of mass locates? About this point. So for cone, where does it locates means you can check in the previous slide. We'll get like h by 4 will get it. H by 4. H by 4 means 4r by 4. 4r they given. R will get cancelled. What will get it? 4 will get in here. Sorry. 4r by 4. 4 will get cancelled. What will get it here? R will get it here. Location. This location. So location we can like 0, r. So for this solid sphere, hemi-solid sphere, what we got it? 3r by 8 we got it. So let me choose outside here. So what we are having here? 0, r. Okay, vertical case we took, no? Let me take like this. 0, r. This is, let us assume COM. And downward what is there here? 3r, 8. 0, 3r by 8. 3r by 8. Fine. Now, this mass also we got it. How much is this mass? We got it like m1 like 1 kg. This is like 1 kg we got it. This is like 2 kg we got it. For this we need to apply XCOM formula. If you apply XCOM formula, XCOM, YCOM, we are discussing about the y axis, no? YCOM we need to apply. YCOM formula what we are having? m1 y1. m1 is nothing but 2. y1 is how much? Just r. r plus m2 is 1. 1. This is below the coordinate axis. Now I have to choose like minus here. So what we can get it here? 1 into minus 3r by 8 divided by m1 plus m2. 2 plus 1 is nothing but 3. So if you solve this, what will get it here? YCOM equal to 8 to just 16. 16r minus 3r. It's nothing but 16r minus 3r is nothing but 13r. 13r divided by 8 3 is 24. 24 will get it. This is the answer for this question which we can give here. What we are going to discuss here means we are going to discuss about the cavity concept. Which concept we are going to discuss here? Cavity in metallic disc. These all things. Caving I am writing. Cavity in metallic disc we are going to discuss here. So generally let me take one system here, one uniform mass system. Let us assume here center of mass is Z. So let me choose this is my y coordinates, this is my x coordinate axis. X coordinate axis like this. And this is y coordinates axis. Like this. So here what they are doing means, here one part they are taking like this and they cut it here. Then where the center of mass is shifted, they are going to ask here. After removing that cavity, after removing that one some mass from the previous body, so what is the center of mass location now located? So let us assume this point is nothing but center of location but for cutted part. So this is nothing but what here you can tell means R cutted part. Means where the shifting will come means this side will come. For remaining mass, shifting will come in this direction. That's why I am going to write here R remaining. R remaining. So this fellow mass can be written as M remaining here. This fellow mass can be written as what here? M cutted we can write it. M cutted. So this is nothing but for what? COM of cutted portion. COM is center of mass. Cutted portion. So this is nothing but what for here? Center of mass for COM of remaining portion. Remaining portion. To solve this type of numericals, it will be regular NCERT, HC Verma, everywhere will be there. This will be useful for CET, NEET and JEE also. So I am going to give only one law. That law what you need to follow means you need to follow this rule. M remaining into X remaining is equal to m cut into x cut. So only this law, if you remember, no, that will be easy to solve the numerical. So just follow only this rule. What is that rule says? M remaining into x remaining equal to m cut into x cut. We can write it here. So let me take a question and we'll discuss that. He is asking, a disk of radius r by 2 is removed from the disk of radius r, find center of mass of the object. So first you take the diagram to understand properly. They given one disk like this, whose radius is what they given? Capital R. From the disk what they remove? They remove whose diameter is r, means radius is how much? R by 2. That much portion they remove here. So where the center of mass is shifting, they are asking. So center of mass will be for sure will shift this direction. This direction will remains here. This is called x remaining. Now if you want no, x cutted portion is how much? X cutted is equal to r by 2. So mass of the cutted portion you have to choose. Mass of the cutted portion is nothing but is nothing but sigma a na. So m equal to sigma a na for surface, sigma a. Therefore sigma into a. Area is nothing but pi r square by 2. Pi r square na. But here r value is how much? R by 2 na. Pi r square by 4 will get it. Pi r square by 4. Then mass of remaining part I have to check. The mass of remaining part means sigma into. So total mass is nothing but how much? Pi r square. Removed mass is how much? Pi r square by 4. Sigma I took directly outside. Okay. Mass remaining is how much we will get it means 3 pi sigma r square by 4 we got it. Pi sigma r square by 4 I am considering like 1 here. This is nothing but 3 times, no? We can write like 3, we can write it here. So what is the law we are having here? M cut into x cut equal to m remaining into x remaining we are having. So m cut value how much we are having here? 1. 1 into x cut value r by 2 they given in the question is equal to m remaining is nothing but 3 into x remaining. Therefore x remaining can be written as what here? If you send 3 here, it will come to denominator. R by 6 will come here. But if you go with coordinate system, no, I can give here one negative sign. Why? Because your mass is shifting negative direction like this direction, no, from center of mass. That's why we can give minus r by 6. This is one standard JEE NEET and it's from NCERT also. So this is for today's class. So dear students, for this PDF of this lecture, you can check in description box. You'll get the PDF of this lecture.